Thank you for joining me this evening to learn a little bit more about the importance of light in the garden. Learning to diagnose plant problems is a lifelong study for a gardener, and here is a gallery of issues. You've probably been faced with one or more, many of these. I know that I have. Yellow leaves, for example, or holes in yellow leaves. Blossom end rot on tomatoes, or maybe on zucchini, or maybe on eggplant. Sunburned leaves, we'll talk about that tonight, or spider mites, or animals and critters in your garden. I have voles and gophers taking over mine. So many things can go wrong with plants. It's a puzzle to try to figure out what's going on sometimes. Yellow leaves, chewed leaves, spots on leaves. This year I have a plant that died for a reason that I haven't yet diagnosed. So many things can go wrong. And what I'm hoping to do this evening is help you identify those problems that are related to sunlight so that you can eliminate them as you try to solve other issues. You may have seen this slide before if you've seen some of our other presentations, and we usually talk about these in the framework of good cultural care. Healthy soil and providing a nurturing environment for plants and soil organisms is the basis for every healthy garden. Water is, of course, really important. Consistent moisture in the soil is key. And aerated soil, soil that has air in it and space for roots to grow and air for the organisms living in the soil to live, is also really important. But tonight, we're going to be focusing on the sun. The right amount of sunlight for plants will help plants thrive. And just as for water, too much or too little can create problems. So, what is light? How do we think about light? We think sometimes about clarity, right? If we put some extra light on something, it means that maybe we want to see it more clearly. Or maybe if we see something in a different light, it means we're looking at something with a different perspective. Or maybe we think of light as the end of darkness or morning, or light, as we see in the image here, passing through a prism. Or if you want to get philosophical, we think about truth. Lux e veritas, light and truth, is the motto of several universities. But what is it in the context of this presentation? I'm going to talk about solar radiation. It's the radiation emitted by the sun. Every place on Earth receives sunlight at least part of the year, and the amount of solar radiation that reaches any one spot on the Earth's surface varies according to its geographic location, including the elevation above sea level, the time of day, the season, the weather. Maybe it's really cloudy and sun's not getting through. And when the sun's rays are vertical, the sun is directly overhead, the Earth's surface gets all the energy possible from the sun. Solar radiation reaches the Earth as a spectrum, a range of types of radiation and wavelengths. So it's a spectrum of light, gamma and X-rays on one side and radio waves on the other. And what you see here is a cartoon. But if you imagine these light as a squiggly line, as these little squiggly lines, as the squiggles get smaller, as you move in this direction, the wavelengths get shorter and the energy gets higher. So the waves are much more energetic on the left side than they are on the right. X-rays are more energetic or powerful than the microwave and radio waves on this side. This middle portion is what we think and worry about in the garden. And by far the largest portion, 99% of the solar energy that reaches the Earth, is in this range. But within this range, only a small amount, 5%, is this ultraviolet over here on this side. A much larger amount, 42%, is visible, and even more than half, 53%, is infrared. So this is what mostly reaches the Earth, the surface of the Earth. And I'm going to focus on those three, ultraviolet, visible, and infrared, and how they affect the plants in our garden. Visible light is in between UV and IR in terms of wavelength and energy. It's depicted here as a rainbow. and it's part of a spectrum. And I've grayed out the colors of the UV and the infrared because we actually, as humans, don't see those colors. So once again, this is a cartoon. The region of the spectrum with the shorter wavelength than the color violet is referred to as ultraviolet, or UV. UV light is high energy, it's more damaging than visible light, and many materials are damaged by it. Plastic, for example, exposed to UV eventually decomposes. And exposure to UV rays is also linked to harmful health conditions, such as sunburn, and it can lead to eye damage and is the reason we wear sunglasses. It can also damage plant cells, and that's how it can affect our gardens. Most UV is filtered by the ozone layer and doesn't reach the Earth's surface. But with the thinning of the ozone layer, more UV reaches the Earth's surface. There are some plant species that limit this excess light radiation by forming a waxy covering on their surface. So that's sort of interesting. IR is on the other side. It has a longer wavelength than the color red. So infrared is next to red, but it has a longer wavelength. And we sense IR as heat. Solar energy in the garden includes daylight and heat. Daylight drives photosynthesis, which we're going to talk about, and it's so important, and it's visible light. And heat warms the air and warms the soil, and it's infrared light. And when I talk about light in the upcoming slides, I'm going to mean this combination of visible light and infrared light. Daylight and heat are related. Heat lags. Each day, the sun is directly overhead in the middle of the day, around noon. And the warmest time of day is a few hours later, 2:30 to 4:30, let's say 3 o'clock. So why is there a lag? Because the energy has to be transferred to the atmosphere, which takes time. So if you think of a pot of water, the flame is hot, pot of water on the stove, the flame is hot, and the water takes time to warm up. And this is important because when the light shines on a plant can make a difference. Afternoon sun is actually hotter than morning sun. Over the course of a year, the temperature also lags. So here, this yellow line, we see a plot of day length. Over here, we're going from 9 up to about, well, the day length gets to about 15. So in January, it's maybe 9.5 hours, doesn't quite hit 15 and goes back to 9.5 when you get back to December. So the longest day is in June. And the orange line here shows the peak temperature for each month. And the peak temperature is in July. It ranges from, maybe 65 or 68 as the peak for the month of January to some peaks that are over 100 in the summertime and then dropping down again. But the peak temperatures usually are in July and August, and that lags just as it does over a single day. So now I'm going to move on to photosynthesis, the magic that brings solar energy to plants. Visible light provides the energy for photosynthesis, and it's mostly red and blue light, visible light, that drive photosynthesis. So what is it? It's a process that uses light energy to synthesize or make something. It uses carbon dioxide and water plus light to create carbohydrates and oxygen. Hydrogen, carbon, and oxygen are essential nutrients, but how do they get into the plants? Plant cells get nutrients from their environment. Carbon and oxygen enter plants through their leaves as carbon dioxide, and hydrogen and oxygen enter plants through their roots as water and also as pure oxygen. So what is photosynthesis? What is it doing with those three things? It's a chemical reaction. Carbon dioxide and water plus chlorophyll and sunlight create carbohydrate and oxygen. And those carbohydrates that are created are critical for all living things. Food carbohydrates originate here. So everything we grow, that we eat, And everything that we make, like bread from something else, like wheat that we grow, starts out with photosynthesis. And other foods that we eat start here too. So dairy products and meat start with an animal consuming plant product. The other thing about photosynthesis that's so important is that the oxygen we breathe is produced by it. The air we breathe is part of this is the result of this chemical reaction, and there is no other source. I say that, but then I think it's important to mention that about half of the Earth's oxygen comes from the ocean. The majority of this comes from plankton, drifting plants, algae, and some bacteria that can photosynthesize. And roughly the same amount, about 50%, is consumed by marine life. So just like animals on land, marine animals use oxygen to breathe, and both plants and animals need oxygen to live. So photosynthesis is super important. The food we eat, the air we breathe are produced by photosynthesis, and without it, we would not exist. And it works because of pigments. So what is a pigment? Most materials absorb certain wavelengths of light more than other wavelengths. And if a material absorbs all wavelengths except for green, for example, then the green color bounces off and the substance appears green to us. So look at this image. The sunlight is shining down here on the leaf. Just as an example, the red and the blue wavelengths of light are being absorbed by this leaf, and the green leaf is bouncing off. In this case, this is a green pigment. Chlorophyll is a green pigment. Plants have different shades of green because of different amounts of chlorophyll in their leaves. Young leaves have a lighter shade of green than mature and old leaves. And as the leaves mature, they become darker green. The amount of chlorophyll pigment creates different tolerances for sun and shade. And deep green leaves contain more chlorophyll. Plants that grow in shade, like those in forests, contain more chlorophyll and are better adapted to growing in shady spots. On the other hand, white areas of variegated leaves, like the edges on these little tiny leaves, do not contain chlorophyll, and they don't perform photosynthesis. So that plant is slower growing. It needs a sunny spot to get the most out of the light that it receives. So you might be wondering, if you have a variegated plant, sometimes they revert to all green. And if that happens, it might be a sign that the light levels are too low. So there are other pigments in leaves. Why do leaves turn red? Well, carotenoid pigments are always present in leaves, and they're usually masked by the abundant chlorophyll that's there, but they produce the bright yellow, red, and orange colors in plants, vegetables, and fruits. And in autumn, chlorophyll breaks down, and we can see the carotenoid pigments in the leaves, and that's why our leaves turn red. So let's just summarize the importance of light. Visible light is the light that's used for photosynthesis, and it's so important. IR is for air and soil temperature, infrared is for air and soil temperature, and ultraviolet is damaging light. And photosynthesis is critical for life. Chlorophyll is a pigment. So I'm going to move on to talking about diagnosing problems now, and this can be tricky and frustrating. So as I already mentioned, you saw this slide at the beginning, you might be confronted with many issues. And diagnosing those issues usually can be a puzzle, and it's easier if you look at them as being possibly from a single source or a combination of problems. And the problems might fall into a couple of buckets: the environment, which includes soil and light and temperature, and care, which can be related to what condition the plant was in when it was planted. So when you picked it up from the nursery, was it root bound? Was it kind of dried out? How healthy was it when you picked it up? And then how was it planted, and what has been done to it since? And what about critters that are in the garden? Insects and mites and other animal pests, they can cause problems. And also infectious diseases, fungi, viruses, and bacteria. And we're going to be talking about light in particular, of course, tonight. So both too little or too much can cause problems. Let's start with too little. When there's not enough light for photosynthesis, the plant will gradually use up its reserve carbohydrates and starve. And adding fertilizer won't help if the problem is related to sunlight. So why do too little light can result in yellow leaves? Why do leaves turn yellow? Well, it could be overwatering. Mature leaves turn brownish yellow and wilt. Could be underwatering. The newest, youngest leaves are yellow and they might wilt. Could be cold, yellow, which might produce yellow leaves or burned edges, or nutrient deficiencies, especially from iron and nitrogen, or too much fertilizer, or diseases and pests, which might produce yellow or other spots. Or it could be sunlight, too little, which gives you yellow leaves on the bottom or the inside of the plants, or also pale green leaves, or too much sunlight can also cause yellow leaves and burning in spots. So you might be thinking, okay, so many things can cause yellow leaves. How do I figure it out? It's a puzzle. It's not going to be easy, but part of the fun and challenge of being a gardener. I'll give you some resources in the handout. By the way, there's a handout that comes at the end, and there are resources that will help with all of these diagnostic problems. A plant that is deprived of sunlight, in addition to yellow leaves, it might reach for light, and it might give you spindly, leggy plants. In some cases, the seedlings might be so spindly and weak that they just flop over, and that's not a good recipe for starting anything in the garden. The stems can elongate, and that's often an indication of low light. And here's an example of a jasmine plant. There's spacing here between the leaves. It's very long. This plant was grown in a low light situation, and this was grown in normal light. And you can see here that the internodes are much longer, and also the leaves are smaller. So are leggy, spindly plants, are they always caused by light? No. The possibilities include rapid growth. There could be new spring growth coupled with nitrogen fertilizers that will cause leggy plants. It could be perennials that haven't been pruned every year, and so they get kind of leggy. Or it could be inadequate sunlight. In low light, plants stretch for sunlight. You can see an example here. This is a plant on my front porch in a pot. It gets no direct light, although there's plenty of indirect light. It's a front yard that's facing south, but there's no light directly hitting that plant, and it's reaching for light. What about limited flowering? That's another problem. If we as gardeners have plants that are supposed to flower in our garden, it's a big disappointment if they don't. And the issues here could include light, or any of a number of other things, the age of the plant. Sometimes young fruit trees don't blossom for a year or two. There are some young other plants, hydrangeas, that don't bloom right away. Nutrition could be too much nitrogen. It could be a variety or the wrong season. So for example, this is a very vibrant, healthy looking rose bush with not a single blossom. I suspect in this case that it's because we're in the wrong season, that it's one of those roses that blooms once and then is done, and we're past that. So now it's just a healthy foliage plant. It could be extreme temperatures. It could be improper pruning. Maybe you've pruned off the buds that are going to bloom. Some plants, oak leaf hydrangeas, bloom on second-year wood, for example. And so if you prune that off the year before, you won't get any flowers next year. Or it could be weather conditions, excessive wind or rain that have damaged the flower buds. So there are a lot of things that can cause limited flowering, including lack of light. Flowers want the right light. There are many plants that bloom in the sun, and there are some that bloom in the shade. Begonias, impatiens, and fuchsias include some of those. And there are some plants like chrysanthemums and poinsettias that flower in response to short day lengths, or actually long nights. And if the plants don't receive the appropriate break from light, which is their season of bloom, then they will be delayed indefinitely, that season. What about limited fruit or vegetable production? No squash or no apples or no zucchini. So this could be a result of an absence of flowers, which we just talked about, or poor pollination. It could be too hot or too cold. for the flowers to set. It could be that you're over fertilizing, or once again, that pruning, improper pruning has occurred. So to summarize, what are some possible impacts of too little light? Yellow leaves, spindly, leggy plants, limited or no flowers on a plant that's supposed to flower, or limited yield in a vegetable garden, or plants simply not thriving because they're not getting the nutrition that they need from photosynthesis, from the sun. So too little light can cause problems. Too much light can also cause problems. Excessive light can be very damaging to tree bark. And when the amount of direct sunlight the tree receives abruptly changes, the extra heat and radiation can damage the nutrient exchanging tissues beneath the bark. Often the first sign of this is that the bark color might change. The bark and cambium just peel back then, and that's what's happened here on this Japanese maple tree. This is a picture of a beautiful over 40-year-old Japanese maple tree in my backyard. I've lived in the house for more than 30 years, and this tree was big when we moved in. And a few years ago, we have some birches that lived nearby, aside those trees, the Japanese maple trees, and the birches are not really suited to our climate, and they were also over 40 years old, and they died one by one. So we removed them one by one, exposing this tree to much more sunlight than it had seen before. And so this limb is severely damaged, and if you could see into the canopy here, you can't really see it, but there's another limb that's also very badly damaged. An arborist that I know, we have a tree guy that comes out to our house every few years to take care of trees, and he's very knowledgeable and I trust him. And he told me the tree will survive and that it's healing, and you can see that it's starting to heal over here on this open space. As long as I continue to give it good care, he thinks it will be okay. And good care means irrigating it properly and providing compost so that there's good material, organic material to support the life in the soil around the canopy of the tree, not on the trunk, but a little bit further away. This toyon tree is another example of a tree whose bark has been damaged. This is not from my backyard. This is from the UC website, this picture. And in this case, the canopy was pruned, exposing the trunk to more sun, and it also responded with damaged bark and sunken bark. So white paint can be used to protect bark if you'd like to do that. Applying white paint to trunks or whitewashing reflects the light and reduces the bark heating, and that will help the tree to avoid sunburn. The paint needs to be diluted with water and should be latex paint, not oil-based. And once again, there's a resource in the handout. If you decide to do this, I recommend you read the careful instructions. The sunburn can occur on the stems or trunks of young woody plants. If their bark is thin because they're young, they may not tolerate being exposed to direct sun. And older trees, as we've already noticed, can be damaged when all of a sudden the light changes and exposes their bark to more light than they were familiar with before. There are some disorders that look like sunburn, and those include some canker disease and water deficit. Too much light can result in sunburn or sunscald on fruit and leaves also. So usually sunburn on leaves is most severe on the south and the west side of plants and on the upper side of horizontal branches, which are not adequately shaded. So here you see on this lime, the sunburn is on one side only of the leaves, and also on this ficus tree that's in my backyard. We had a lot of sun last summer, so this hedge was also sunburned. So you might be wondering, what is the difference between scorch, sunburn, and sunscald? Well, just for starters, scorch is not due to too much light. In general, large volumes of water leave the plant through the leaves every day. all the time. And if after the water leaves, the plant is not able to replenish that because there's something wrong with it, the tissues have been damaged for some reason, then scorch occurs. And that happens because the water isn't able to then flow into the damaged tissue. So leaf scorch is caused by an environmental factor, including maybe a salt or a mineral toxicity in the soil. Too much salt could be too much fertilizer, or something that's damaging the leaf tissues. In this example, the oak leaves have scorched margins because of an oak gall wasp feeding on the leaf undersides. And over here, you can see leaf scorch occurring along the outside edges of the leaves, which is where leaf scorch occurs initially. So I want to just emphasize leaf scorch is about water movement and less about sunlight exposure, whereas sunburn and sun scald are caused by high temperatures combined with intense solar radiation. Sometimes you may want to provide shade. Especially for new landscape plants, they can benefit from sun protection. So here we see a handful of tomato cages that are covered, draped with a cloth, and then clipped on just to protect the plant from the sun. It could be cloth, it could be shade cloth, but just don't use a plastic sheet, which will trap the moisture and maybe even magnify the light. The other thing you can do is put a small rock on the southwest side of a plant, and that'll provide a little bit of shade for that plant and a cool, moist area for roots. Managing shade can also be useful in a veggie garden. Even heat-loving plants like tomatoes and peppers might need extra care during a heat wave, and seedlings of fall crops, broccoli, Brussels sprouts, cabbage, and cauliflower, are also susceptible to heat because we plant them at the end of summer and early fall when there's still quite a bit of heat and intense sunlight. And there are plants that you will benefit from the shade from a neighbor plant. So plants that are a little more tender, basil, lettuces, and cilantro, if you plant them in the shade of a taller vegetable, a pole bean, for example, or a tomato plant, then those plants will benefit from the shade that the others provide, and that will help them thrive. So here's some ideas from master gardeners. These are some master gardener gardens and what they've done providing shade in their own vegetable garden. So this is a series of cabbage plants that has a nice little structure erected over it to keep them shaded. I think that the master gardener whose garden this is said that these were planted in the spring, and so they're heading into summer, and she wanted to protect them from the hot sun. And here is a hoop house with some shade cloth on it over some Swiss chard, and here's a very simple shade structure that's rigged up to protect these little tomatoes from too much sun. And you can also see in every example here that the gardeners have protected the soil from sun with a straw mulch to keep the soil a little bit cooler. So what have we learned about too much or too little light? Well, plant issues usually fall within a couple of buckets: environment, care, animal pests, and diseases, and light is included in the environment portion of that. And that the damage or stress could be a result of a single issue or a combination of problems. And understanding how light affects plants will help with diagnosing plant issues. And if the problem is related to light, what can you do? Well, for existing plants, if possible, move the plant or move the shade. Now that sounds kind of silly, but really that's what it comes down to. If the plant is small enough and you're able to transplant it, then do that if it's in the wrong location. If you're able to erect some kind of a shade structure or plant something taller next to it that will then provide some shade, then do that. But if you're starting with a new plant, learn about the light requirements and plant accordingly. Right plant, right place. You've heard this probably a million times, but many factors will contribute to whether or not a plant will thrive, including, is the zone the right zone for the climate? And what about the soil? If the plant is a desert plant, and then it wants to be in some kind of sandy soil, not really very dense clay soil. So provide the soil that that plant wants. Make sure that the drainage is good and that there's life in the soil that, in order to provide the nutrients that the plant will need. Also, make sure that the plant is intended to get the amount of precipitation or irrigation that you're able to provide. We live in a Mediterranean climate where there really isn't any moisture most of the summer. And so it's a good idea to plant plants that are suited to that kind of a climate where there's no moisture for a good part of the summer. And also, of course, think about the sunlight, the hours of sunlight that are required for the plants that you want to put in. So what does that mean? If it says full sun on the label, that means 6 or more hours of direct sun per day. And in nature, that would be a meadow or a prairie. And full sun in Brentwood is hotter than it is in Richmond. In Richmond, there's more moisture, there's a sea breeze, the air is cooler. So even with more hours of sunlight, it's going to be a cooler situation for the plant. Shade is a little bit more complicated than full sun. So light shade usually means between 3 and 5 hours of direct sun in the summer. And partial shade means 2 hours of direct sun. And full shade means less than 1 hour each day. And dense shade means there's no direct sunlight and very little indirect sunlight. So you need to assess the need for light, the plant's requirements, look at the labels, and know that they're not the full story. Plant tags are most likely not made for the specific region in which the plant was sold. In our Contra Costa County, full sun, as I already mentioned, in Brentwood, is a more intense situation than full sun in Richmond. And there are growers who try to help. There's a local grower who puts this label on their plants, sun, if it's sold in Richmond, if it's planted in West County, and part sun if it's in a hotter part of the county. So use a variety of sources to collect the information on what that plant requires. So for example, maybe you're interested in Salvia microphylla heat wave blaze. This is a great plant and it withstands our hot summers here in Central County. So there are some local nurseries where the label says full sun, partial shade, and another where it says sun, and another where it says sun, part shade, and another full sun. So you can see this variety, these are similar, but they're not the same. And it behooves you to study what that plant might need and how it might best fit in your own garden. There are plants that can tolerate a lot more sun if it's morning sun as opposed to hot, scorching afternoon sun. So for vegetables, light needs vary. Plants that we grow for their fruits, need 6 to 10, closer on the 10 side usually, of sun every day. Plants that we grow for their roots or flowers need 4 to 6. Plants that we grow for their leaves need even less, maybe 2 to 4. And there really aren't vegetables that we grow in the shade. And what happens if light requirements are not met? Well, the plant's going to be stressed. It'll be susceptible to pests and disease. It might look okay for a year or two, but eventually it won't be able to fight off the problems and it will fail to thrive. And even if it does survive, it will never look as good as it would if it were in the correct environment. Morning sun versus afternoon sun, as I've said a couple times, is different. Morning sun is safer and cooler than afternoon sun. Why? Because as we've said, both the air and the soil surface heat up as the day progresses. The hot sun and high temperatures can be really tough on a garden, causing plants and gardens to wilt. The ability of a plant to withstand that intense sun can be based on the temperature of the air, the soil temperature, irrigation practices, and how well the plant's established. When the summer days are really hot for days in a row, it can be helpful to erect some form of shade over even sun-loving plants like roses for the afternoon heat. So as we've already said, solar radiation is going to warm the soil. And that soil will hold the heat then better than the air. And on a cold day, it's usually warmer than the air. And the sunlight can be beneficial for the soil because its warmth will encourage the soil organisms to be more active. However, too much sunlight on uncovered soil will make it dry out faster and kill microorganisms. So use mulch. Protect the soil surface. We already showed you some straw mulch in a vegetable bed. You might use wood chip mulch. You might use gravel, but put something on your soil to protect the surface of the soil in the hot summer. Plants that are grown in raised beds or containers, those containers will warm more quickly in the spring than the soil in the ground. And that's an advantage for those of us who plant vegetables. We want to get the tomatoes in as soon as we can. And so we're waiting for the soil temperature to reach what we think is the right temperature for our little tomato plants or pepper plants to go in the ground. If the sun shines directly on a container, however, especially if the container is metal, the soil can get really hot. And in that case, it can burn the roots and dry out the soil. So if this is your situation, you might consider draping some shade cloth or something else over the container to protect it from the IR and keep the metal a little cooler. So what are light needs at different stages of a plant's growth? For seeds, light can stimulate or inhibit the germination of some seeds. Usually seeds will grow regardless of what light there is, but there are seeds that can either grow in dark or grow in light, and they won't do the opposite. Seeds that require light are usually very tiny. So my advice here is to follow the guidance on the seed packet. The seed packet will give you good, clean information. There are also 2 references in the handout that identify which seeds need light and which need darkness. But don't confuse light requirements for seed with what the seedlings need. The seedlings all need light. Foliage, on the other hand, foliage is mostly controlled by visible light. And plants that are growing rapidly, flowering or fruiting, they need lots of energy. And so they're going to need plenty of visible light for that photosynthesis to give them that energy. What about flower development? For plants to flower, they need not only visible light, but also some IR. They need the warmth. And the flowering is often controlled by the relative length of the daylight and the dark. There are some plants like chrysanthemums and poinsettia that are short day plants and they flower in the winter. And there are some that are spinach and beet, for example, they're long day plants and they flower in the summer. But most plants, the timing of the flowering will be affected but not controlled by the day length. Some salvias, for example, flower on short days. They're flowering right now in the fall in my garden, the salvia leucanthas. They're bursting. But eventually they'll also flower on long days in the summer. So this is a little backwards. In my garden, I got 1 or 2 purple spikes on those salvia leucanthas in the summer, but they really burst into bloom when the days are short, which is now. On the other hand, there are many petunia varieties that flower most rapidly on long days, but they will finally flower also on short days, as short as 8 hours. So petunias will bloom in December. They'll bloom on Christmas if they don't freeze first. What about bulbs? Bulb development can also be controlled by day length, and onions are a great example. The bulbic phase in onions is triggered by day length. It could be that you have a short day bulb, and that bulb will produce a bulb when daylight hours are 11 to 12 hours per day. An intermediate day onion will produce a bulb when the daylight hours are 13 or 14 hours per day, and the long day 15 to 16. Well, as you know, because I mentioned it earlier, we never get to 15 or 16 here in our county. So you don't want to plant a long day onion because you won't ever get to the bulbing stage for that onion. If you plant the wrong day length onion, you may never produce a large onion or any onion bulb at all. What about winter? What happens in winter? So I'm going back to that plot that I just mentioned. In Contra Costa County, the day length ranges from 9.5 to almost but not quite 15, and then back down in December again to a little bit less than 10. In fall and winter, both day length and the temperature are low, and plant growth is relative to day length and temperature. Crops need more days to mature in winter than they do in spring and summer. It takes more time because little photosynthesis is occurring, even for evergreen plants. Both deciduous and evergreen plants rely on their stored nutrients during the winter. When the daylight falls below 10 hours per day, plant growth nearly stops. And this is known as the period of Persephone. You heard about this last month. If you heard Marion Woodard's talk on vegetable gardening in the winter, she mentioned this. The period of Persephone in our county, when the daylight is less than 10 hours per day, runs from about November 19th through January 21st. The story about Persephone is a Greek myth. In the myth, Persephone was a young goddess who was carried off by the god of the underworld to be his bride. Persephone's mother, Demeter, who was the powerful goddess of grain, prevented the earth from bearing fruit unless she saw her daughter again. By eating a few pomegranate seeds, Persephone was required to remain in the underworld for about a third of the year, which is the period we think of as winter. In the story, Persephone's return from the underworld each year is marked by the arrival of spring. Well, of course, January 21st is not spring, but it's a story. So how do you plan for the low light period in a vegetable garden if nothing's going to grow during that period? Well, it can be tricky. Overwintering crops are hardy vegetables that you need to harvest, that you plan or want to harvest in winter or spring. And so the examples might be cabbage, broccoli, carrots. And these need to be at least 75% mature by the beginning of this period. So by November 19th, those plants have to be 75% mature if you want to harvest them in the spring. And they need to be close to 100% mature if you want to harvest them in the winter, because they're not going to grow much more beyond November 19th. As we said, not much happens during that period where the sunlight is less than 10 hours a day. So when you're planting transplants, you have to estimate how old the transplant is and then how old it's going to be on November 19th based on the conditions in your garden. And that's tricky. I volunteer at the demonstration garden in Walnut Creek called Our Garden, and our garden manager, Janet, plans very carefully to be able to harvest through the winter. There's a good resource in the handout that explains in detail how to do this, and I think the title of the resource is something like Planning for the Period of Persephone. So you might be wondering, what about cloudy days? Well, as you can imagine, cloudy days, sunlight is diffused and photosynthesis is reduced. And much less light photosynthesis is happening on cloudy days. It can go down to very low if it's a very dark, gloomy day. So how do you use this information in your own garden? Well, for starters, you need to be a careful observer. Look for the sun in your garden. Here's a home in Concord, a sketch of an imaginary home in Concord. The front yard of this home is facing south. This is the street out here. The backyard is facing north. So this fence line here, this fence faces the south side, right? So this vegetable bed is on the south side of this fence. We're going to look at a couple of pictures of this as on the next slide here, and try to figure out where's the best place for that vegetable bed or anything else that might need full sun in this garden. So this image on the left is in the summer and it's in the morning, and the image on the right is in the fall and it's in the afternoon. So in the summer, in the morning, the shadows are short. Our vegetable bed is in full sun. And in the fall, the shadows are much longer and our vegetable bed is in the shade. And if I were going to make one suggestion to this homeowner, I would say move this vegetable bed a little bit over more to the right, where you can see here that it's still going to get full sun if it's slid over a little bit to the right, and it might avoid the afternoon shade that's coming from these tall trees. So notice that these trees are the neighbor's trees. You can't always control what's going on in your own garden. It could be your trees, could be the neighbor's trees, but they're going to give you the shade, or once they're removed, they'll give you more sun. So be an observer. Draw a simple sketch of your own garden. Write down where the sun is. Do this for different times of the day and in different seasons. And know that the angle of the sun is going to affect the results. The northern exposures will become shadier in winter, and southern exposures will have more sun in summer. And that light might change, just as it did in my yard. So young trees and bushes will grow and might produce a lot more shade in your garden, or they might be removed. And all of a sudden you have a lot more light than you perhaps wanted on a shady area. Also, structures can change. Fences can be built or removed. Your neighbor might put on a 2-story addition that all of a sudden throws a lot of shade on your light. And the impact of these changes can be significant. Sun damage can be severe, and you might end up with shade where you don't want it. So use what you know about the sun to guide your garden planning. Vegetable beds need full sun. Southern exposures heat up earlier in the spring. Good spot for warm season vegetables is on a southern exposure, as it was, remember, for that vegetable bed in our little garden sketch. Shade-loving plants are best planted on the north and east side of structures. And a north-facing wall or slope will receive limited sun in winter and nearly full sun in summer. The east side of a house is nice for a patio. It gets the afternoon shade in the summer. Houseplants are a special case. They have lots of issues with respect to light, and providing the light can be challenging. There's a great webinar on our YouTube channel which talks about this, called Houseplants Gateway to Gardening, and it's at this link. You'll be able to get to this video later, so you'll be able to catch the link then. So let's summarize. Energy from the sun includes visible, IR, and UV. And photosynthesis is critically important for all of us. Diagnosing plant problems can be complex, and identifying light-related issues might help you solve one set of possible problems and eliminate those from the puzzle. If you plan and understand a plant's light requirements, then you can put the right plant in the right place.